Once we have this, we can run it. And as each node runs, it emits events or traces. And as these sort of events come out, you can sort of look at them here. And essentially, you can also see that visualization that sort of shows you as a developer what's happening at each time as your entire workflow gets executed.
Hello, everyone. Welcome back to Open at Microsoft show. We have Evan and Victor back here to talk about Microsoft Agent Framework. Hey, guys. Yeah, what are we going to talk tonight on this episode? Evan will be workflows. Tell me.
Yes,
Welcome.
we are going to bring you another series here about Agent Framework. We are super excited to introduce it at the beginning of October. Have some wonderful feedback so far as we work through public preview. But today we are going to dive into Agent Framework workflows. So Victor and I are going to present these to you today, explain why you need workflows, the benefits of workflows, the abstractions and patterns that we support. And so we are going to dive into that. I guess, you know, first, my name is Evan Mattson. I'm a principal software engineer on the Engine Framework team. We have Victor with us. Victor, do you want to say hello?
Hi, everyone. My name is Victor Dibia. I'm a principal research software engineer. Um, I used to be on the AutoGen team, and now I'm on the Core AI team. And we're all sort of working together to make Agent Framework a really strong, compelling experience for everyone to build the AI agents.
And then,
Definitely.
Evan, that's a nice thing, Victor and Evan. Like, people to understand that those teams now, Semantic Kernel and AutoGen, they're working together. So we
Yes.
have a stronger team working on Microsoft Agent Framework. And that's a big, advantage, I think, going forward. So we are all excited to see what's coming and understand a little bit more about workflows.
Yes. And I just have to say, I'm super excited that our teams are now together and we get to use the experience of both sides and bring this amazing framework to the community. So let's get started. Let's talk about workflows. For those coming from semantic kernel to agent framework workflows, there are going to be some of these abstractions that look familiar, but I do want to say it's workflows is a complete rewrite of process framework. We had received amazing feedback from it, but also knew that there were some shortcomings, and so we wanted to provide a better developer experience. And so we're just going to talk about some high level, I guess it's high level, but core abstractions. And so we just want to communicate that a workflow is a deterministic orchestration of executors or nodes through edges that you can configure. And so they're really they excel when you need more than just prompting. Agents can work well together and go off and figure out, work on a task for you, but sometimes you need explicit, deterministic stepping through a DAG or a graph. You want this step A to lead to step B to lead to step C. You want the ability to fan out. You want the ability to fan in. You have these more complex scenarios you need to represent. Your business process isn't potentially just linear. And so you have these abstractions that let you put these pieces together and build this really complex workflow that is audible, stateful, and things like that. And so we're introducing these executors. We're using this executor as a base class that can consume these typed inputs and expose these annotated handlers. We're really putting this type safety typing, heavily into the API because we want it to be robust. We want there to be upfront validation, which we'll talk about soon, and we want to really make the experience so much better than what we at least had in semantic kernel side, and so that if you don't wire things up properly, you'll know upfront. And another component is the workflow context. And so this is allowing you to send messages between executors, yield output, provide results, and we'll dive to more of that in a couple slides. And one thing I really like about these new APIs is the fluent builder notion. And so you have your workflow builder You'll be able to add these edges. You can set the start executor and build it all in this really nice, concise code. Really easy to understand as you're putting it together. It's not extremely verbose, but it allows you just to understand how you're plugging these different methods together to build that graph. And calling out too that part of the core abstractions we're supporting conditional edges or allowing easy fan in, fan out. This is what I mentioned earlier about representing your business process now as this AI workflow. And importantly, it's supported today in Python and .NET. So for those developers who are working in those languages, you can get started really easily with those two languages.
And that's what when people asking about other languages, some people about asking about Java and other things. I think that is an open source project. We need more
Definitely.
people to contribute and see how that can grow in the future, I think.
Yes. So let's continue from these core abstractions and actually look at what an executor and an edge look like in Python. As you can see on the screen, so the uppercase is a subclass of an executor. So this is something you write you bring your business logic. You have some need. This is your node, and you can have message handlers here, and you can see we're decorating the to uppercase method with a handler. So we know that this is going to be part of our graph. It's taking in a text type string, and so we have that text type string, annotated here, and then we have a workflow context, and that's also explaining that we have it typed as a string. That means that it's going to send a message that is of a string type. And as we wire these together, again, we're really putting emphasis on this typed message handling. This allows us to figure out, can this node send information to the next node? Can it receive this type? If it can't, we can validate that up front, and we can provide the user with a useful log message or error message if things aren't connecting properly. So that's an example of a subclass executor. You can also just bring a pure function style executor and decorate it with the executor um, decorator, as you can see here. So you're giving an ID. You're still annotating the method signature, the function signature the same, text string, and then workflow context. But in this sense, we're actually yielding output. So unlike the previous to uppercase executor, this one it can be a terminal node, and we're handling whatever logic is inside of it, and then we're yielding output on the context. So you can see it's annotated with never because it's not sending a message to another node, but it is producing the second type string, and so again it allows us to do the validation and things like that. And then we mentioned in the previous slide that there's a Fluent builder. So we can see the workflow builder adding an edge. So we're adding uppercase, it has an edge between uppercase and reverse text. And then we're just telling the workflow that the start executor is our uppercase executor, and then we're building it. We get a workflow object type back for after we call build. And so, adding edges, we'll get into this in another slide, but it can be an executor edge. It can also be an agent edge. And so, one thing as we built out these workflows, we wanted to integrate as part of agent framework the ability to easily add agents as nodes. And now you're able to wire up agents with other function style executors or whatever business logic you need between those two in a really, really easy manner. That's really first class support for agents is at top of mind for us. And so
And
we
that
do want to
Evan,
call
that
out. Yep.
just
Go ahead.
like that become very powerful when you have agents on those, on those nodes.
Exactly.
People don't
Right.
understand like the power if you have in your hands now with a simple workflow and agents will be on those nodes. Amazing.
Exactly. And
Love it.
that's one reason that we wanted to make it so easy. With in the process framework, all you had the ability to do was create these executor style things. There were kernel functions, and you had to wrap your agent instances inside of them and handle these different dependencies. It was so verbose and I would say clunky. So now we're just giving the ability to create these agents, add them as nodes. We handle all the message brokering between those, and so it's using underlying abstractions that we built out, and it really makes the developer experience, I think, much richer and more valuable. And so speaking, you kind of touched upon this graph validation a little bit. It's the type messaging that the typing that gives us the ability to perform this graph validation up front. We really want to make sure that while you're building these workflows, that you're knowing that you're wiring up these edges and nodes properly, and not allowing you spending all the tokens and usage to later figure out, oh, I can't actually send message to that node. We're saving cost by doing this validation up front. I know that in Python, not everything needs to be typed. We're an enterprise SDK, and so we want to make sure that things are typed as much as possible. It's a little extra work to figure out the types on things. We do these checks up front, even if you're not typing the workflow context properly, letting you know, hey, please give the type of what you expect. It can be a union, it can be complex types like data classes or such. So you're not limited to just primitives, but we really want to make the experience as robust as possible. And so along with just graph validation, we're doing edge checks, making sure that the particular edges can send that information to each, and raising these failures for mismatches. And then also, if you wired up a graph and then potentially an infinite loop, we also want to help you understand that that could be an issue. That's okay to have cycles and graphs. It's okay to have termination logic inside of your executor. We're just going to let you know, hey, double check that everything's okay, that you are exiting, and providing that yielding output as you expect, so that you don't get into some situation again where you're just wasting tokens and you're never going to exit. So it's kind of a not something you want to get through if that happens. And the other thing is that, as I think from the semantic kernel perspective, I talking a lot about semantic kernel. I was previously on, semantic kernel team. And so one thing that there was a disconnect with is that there were different APIs between orchestrating agents and running process framework. And so we wanted to bring in, workflows as the base orchestration layer and build APIs on top of that to give you really easy ability to configure sequential orchestration, concurrent orchestration, magentic, and group chat and handoff, which is coming soon. So we provide these sequential builders, concurrent builders, and so on out of the box. You're able to add agents to it. You don't have to worry about what that means to add the edges underneath. We do that for you. So you're able just to give the participants of these builders configure, for example, for concurrent, a particular aggregator, custom aggregator if you need to. Otherwise, you can use ours out of the box. Or even with Magentic, now you're able to specify the participants. You can have human in the loop to help, move the plan forward. It's not just kind of a one directional piece now. And you get all these other things too, like checkpointing, which is built in as a first class, pattern. So these are really, really wonderful out of the box patterns. We're getting some great feedback. We're still looking at how we can improve these, simplify these, so the dev experience is really good. But these are present, and so I want you to play around with them, use them, build with them, and let us know, what else you'd like to see. And want to also touch on what the execution modes are for workflows. So we provide 2 execution modes today. There's a non-streaming, which you're going to call run method on a workflow. And that's going to run through the entire graph, and then it's going to allow you to get the final state and get the outputs. And everything underneath is actually event driven. And so we're producing events through, the executors. So your business logic can raise custom events. You can handle internal events. You can see the state and things running between what your executor is doing and also what internal states are. And so you get that differentiation. And then on the other side, if you actually want to run it as a stream, you have that ability. So now you're able to, get an async generator of the particular events, handle those. Really useful for UI components, showing what you want to show as a developer to your customers, and getting that final result too. And so as you can see on the screen here, we're able to get that final output event based on the workflow output event type. And Victor will show this soon as we get into some more tangible demos. But let's just touch base quickly. I don't think we'll have time to go into all of this today, but I just wanted to show that there are some advanced features, really exciting things that we didn't have present in the process framework. You can actually just call the as agent method on any workflow, and you just turn that workflow into an AI agent. You can now interact with it in the same with the same interface as an agent has. It accepts chat messages. It produces chat messages. You can get run events. Using the single agent experience translates directly to this, and it's a super powerful experience now to create this complex workflow and just interact with it as if it's an agent. So that's available today.
That's
The other thing,
amazing. That's
yeah, that's
amazing.
that's a really exciting thing, that the powerful thing that we're getting some awesome feedback on, and loving seeing what people are building with. And there's going to be more coming soon around using a workflow as an agent. And so we'll say kind of a teaser. Stay tuned for that. um, the other thing that we're providing right out of the box, is, as I alluded to earlier, talked about earlier, is checkpointing. Checkpointing is such an important concept. When you're getting into these complex scenarios, not everything is running through the happy path. There are issues, there are timeouts, there are errors from agents running underneath. You want the ability to rehydrate your workflow from a particular state. Victor, I saw it. You
Yeah,
want to?
yeah,
Yeah, please.
yeah. I was gonna say it's an extremely useful pattern, especially if you were gonna build stateless applications. Um, so you can think of a scenario where you have an endpoint and you have this thing integrated over, let's say, an interface like Teams or Slack or WhatsApp. And there's always a chance that, like, from those interfaces, your application endpoint gets like a trigger, starts up a workflow, and maybe it needs user input at some point. And so a checkpoint, using the checkpoint feature is a good way to say, hey, I need user input. I might serialize current state to a checkpoint, send some sort of information to the user. The user
Yep.
might respond to that at any arbitrary time. But in the meantime, you have a checkpoint, you can stop that service, sort of spin it down, and then when some new input comes back, you can sort of rehydrate that service, rehydrate your checkpoint, and sort of continue with execution. So I just wanted to call that out because a lot of times people run into this situation where they need to build this sort of stateless, scalable applications, and having thinking in terms of checkpoints is a useful thing to do.
Definitely.
That's essential. That will be very important for the enterprise. And most of the workflows probably going to need some kind of checkpoint.
Definitely.
That's
And today for checkpointing, at least in Python, we support an in-memory checkpoint. We support a file checkpoint. We're going to have more checkpoint storages soon, Azure Cosmos DB,
Mhm.
other providers. But that, just the fact that we already have this in public preview and are able to receive feedback and iterate on it is really important, because it's
oh,
something we always wanted
Yeah.
in process framework, and it
yeah.
wasn't to the same level it is now.
Oh, Evan, and
Yes.
also if you're watching these, you want to help on those new kind of storage. I think that's your opportunity.
Yeah,
Partners.
definitely.
Yeah, that's
Yes,
your time to have your storage available there as well.
exactly right. And that's the beauty of being the open source project. We're open about all this to the community. We're not hiding anything. Let us know if there's a particular provider you need, and as George said, implement it if you really want to, and help us out. We'd love the contribution. Um, okay, so all right, checkpointing. We talked about checkpointing. Another super powerful concept, and one that we provide out of the box, is nested workflows. So let's say you have a particular process you've already modeled as a workflow. You can now run that workflow as a sub workflow, as a node. You can have human in the loop even in that sub workflow, and we will handle all the message routing to get that up back to the user. And so I think it's an extremely powerful concept. You can package that workflow as a sub workflow and bring it in, and elevate your other workflow with that. And then yeah, we've touched on this already, but human in the loop is a first class component here. And so fact that we already are providing human in the loop, it was really asked for from semantic kernel side. I know AutoGen had some really good way of handling human in the loop from agent proxy and things like that. But now bring it into this workflow that is typed message driven. It is stateful, has checkpointing, and the ability to allow the user to more easily integrate into that, because not everything needs to be AI driven. You're creating a bank application and you still want a human to give thumbs up, thumbs down on some things. That's totally fine. We all envision these AI agents running off and doing things for us. And although we may be there in some regard, other times it's perfectly okay to have human in the loop, right? And so we're giving this first class construct here, allowing that to be really easily integrated. We have samples around that, but we will be able to dive into more human in the loop probably in the next segment.
I think those features here will be very important. I think everybody should be using most of them. Run this as an agent. I think will be helping to integrate with other platforms, checkpoints, to keep state, sub flows, and human loop. That's what's most real life
Right,
workflows will be asking for. Congrats
right.
on the team. Very nice. Wanna go
Yes.
for Victor now? Show this running
Yes.
or
Let's get over, and we've been talking enough of showing all this
Yeah.
stuff. Let's dive into
I need
the Dev
you to
UI
share
again.
your
Victor, how
screen,
do
Victor.
yeah, I would love to see how we get to use workflows with Dev UI.
Yeah, absolutely. Um,
1 second, 1 second. Let's put here. Just before you start, make sure that if you're following, this show as part of Microsoft Developer YouTube channel, there's also the first video that we did on the Microsoft Agent Framework 2 weeks ago. Is on the video description. We get a lot of attention, more than 30,000 views now. Make sure that you watch and follow the project here on GitHub. Put the link here at the bottom. So make sure that you leave a star for the project. I know that we have a lot of stars already. Congrats for the team because it's a big achievement to get like 4,000 stars in 2 weeks. And yeah, let's see now that running. All yours, Victor. Go ahead.
Yeah, so let's look at some code just to make what Evan has talked about just a little bit more concrete. And so in this very simple code snippet we're looking at, we have a workflow builder, has a name and a description. The first thing we want to do is we want to set a stat executor. And so what are all these executors? So if you scroll up here, we'll just see that we have things like a final processor, and it inherits from the base executor class that Ivan sort of referred to. So the top part of all of this is that we have defined all of these executors. And now at this section of the code, we will sort of build it into a workflow. And the API is actually quite comfortable. So we set a start executor. We construct an edge between these two executors, even yet another edge. In this case, what we have is some sort of conditional edge. And in this case, we're saying if we have a specific case, we want to enable a transition from the spam detector to a specific handler. And then similarly, we might add additional edges. And once we're done, we sort of build this and we get a workflow object. Now, you probably saw in the previous video, we have like a UI application that ships with Dev UI, a sample UI app. And if we sort of import that, we can wrap our workflow just like we did with agents in the last video. And then we get a user interface that lets us sort of interact with this workflow. And so the exact code I just showed on the Dev UI endpoint, what happens is that we can dump that workflow as a JSON, and we can use that information to sort of render it in a user interface that looks like this. So we see the exact same things we just looked at, the email processor, content analyzer, all of that. And in order to run this, what DevUI does is that it will introspect on the data type of the first or the start executor, and it will give us a form that lets us provide the right input to that node or that executor. Once we have this, we can run it. And as each node runs, it emits events or traces. And as these sort of events come out, you can sort of look at them here. And essentially, you can also see that visualization that sort of shows you as a developer what's happening at each time as your entire workflow gets executed. Then once we have a final result, we can sort of view this in a bit more detail. Now, a workflow can be as simple as this, or it might be something even more complex with fan out edges, so edges that execute in parallel, and aggregator nodes that sort of aggregate the outcome of multiple edges. And similarly, the input to these nodes might be complex. They might be complex pydantic or data class models, and it will run in a scenario where nodes execute in parallel. That will work, and in cases where inputs from multiple nodes get aggregated, that will also work. And so for this specific node, for the data ingestion node, it's a fairly complex input data structure. Essentially, what we do here is that we introspect on that data structure and we can construct a form that lets the user provide the right input. And so before I close out here, the final thing I wanted to touch on was that in addition to executors just being either classes or just pure Python functions, they can also be agents. And in this case, we have agent executor nodes. And if we sort of run this, we would expect that we get some type of prompt, let's say, write a report on AI models and advances. And once we run this, what we expect is that this agent has an LLM. It might have tools. It sort of starts to sort of take the prompt, its system message starts to sort of generate text that addresses that. And once that specific node is done, sort of control is sort of sent or passed to the next node. And as data sort of comes out, it gets streamed to the UI. And we get all those events. We show that to the user. If hotel traces are created, we sort of see that. And then finally, once all of that is complete, we can sort of look through all the output that comes out of all of the executors. I think the important bit here overall is that if you do have specific complex business logic, and you do have a specific order of steps in which you want these things to sort of be executed or explored when the task is run, the workflow API is just the right place to sort of implement all of these. If you're coming from the origin side, you probably have worked with GraphFlow. We tried to handle something similar, but just didn't provide the level of control that we have here. So I definitely would recommend you sort of check this out and definitely leave us a bunch of feedback.
So
Evan?
nice. Yes. Thank you so much for showing us this. I love it. Always dreamt of having a visualizer for my workflows in such a nice, clean way. And so I'm glad that we are able to ship this now.
Yeah, that's I love. You did show me that before, Victor, and every time that you show me, like, I'm in love with that UI and how easy it's for, just to debug, change your workflow, try again. And keep in mind, that's all running in your local environment.
Yeah.
It can be connected with a model somewhere, but it's so powerful for the developers. What kind of feedback you getting so far from those workflows?
Oh yeah. So one of the things that like you sort of touched on one of the key feedback that we've gotten so far. So there are two large things that we've gotten. So the first thing is people want even more richer data about the state of each node. So for example, right now we tell you about like we get events that get streamed out when we do like run stream. So it tells us things like workflow events. A node is currently running, a node is completed, and that's sort of what we use to sort of implement the visualization we just saw. But more importantly, nodes can mutate state. And so Evan mentioned that there's a concept of workflow context, and each of these nodes have access to that. And they can mutate, update the workflow context. Um, and so it might be useful to sort of see, as each node executes, how does the workflow context change? And so we're sort of thinking of nice, useful ways to represent that to the user in a debugging interface like this. And another useful thing would be to sort of show the input and output for each nodes, especially during runtime. And so as each node executes, the output that it produces becomes the input for the next node. It can be helpful to sort of inspect what that looks like just to make sense of the behavior of the entire workflow. And then finally, there's a concept of hot reload. And so the happy developer experience is that we make some changes to files on disk. And once we save that, then the UI is aware of that and we can we can be notified and we can reload those files just for a much smoother debug experience. We have a PR ready for that, and all of these things. It's all great feedback. Um, we're really thankful for all the engagement so far. So hey, keep them coming. Yeah.
Yeah.
Yeah, sure. It's a sure thing. Thanks a lot. Have anything you want to say, Evan, for the community?
No, we love the feedback we've been receiving. We love for you to try it out if you haven't yet. We have weekly office hours. You can join. It's still under the same semantic kernel autogen series. Um, file issues, open a discussion. The team is actively triaging these things and going through them, which really appreciate the support we received so far, and really excited for you to try all this out. Again, so much more to talk about. We probably have to do another series or another video on this series about workflows because we have those advanced topics. But if you're eager to look into those now, we have a lot of getting started samples in the repo. So please dive into those, ask questions, let us know what you're building.
Yeah, and make sure that you follow. I'm going to put also, Victor is doing like on LinkedIn, like a blog post series, and that's amazing. So I'm going to put on the video description that as well, and give us feedback. Thanks a lot, you two again, and see you on the next one. For sure, you're going to
Thank you for
bring
having
more
us.
content on the Asian Framework. So thank you.